calculator handy as well. Again, as always, if we're doing a question and I sense that you're not typing on your calculator following along, I'll lovingly call you on it. That's one of the things I always look for. It's pretty obvious, so make sure you're typing along. Right now, I'm going to call this the distance equation. Right now, you haven't learned enough physics. This is boring. This says that your distance is equal to your speed times time. That's not quite accurate. This is only accurate if I don't let you step on the gas or hit the brakes. Fancy word, if I don't let you accelerate. And we're going to talk about acceleration tomorrow. We're still hoping, and I think it'll happen, you won't have any homework for your long weekend. That's the goal. And then we'll really dive into kinematics next week. But we can do some nice stuff just with this equation and this concept already. It says Jeremy is driving. Oh, last day we also introduced you to your first physics, I'll call them word problems, but they're not like the math word problems, which are terrible. What I said to you, Zaina, was when you give me a word problem, the first thing I always ask is, hey, what are they asking me to find? And I'll often write that down with a little question mark next to it because I've written something down, I feel better, I'm more relaxed, and it helps me focus. So Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers and in meters? Okay. Jada, what's this asking me to find? How what? So how far, which of these three physics concepts is how far? Distance or speed or time? So I'm going to write D equals question mark. Can anybody see why this question is a bit yucky? Yeah. The units don't all match. So one of the other habits you'll pick up as you're reading a physics problem is you're going to just check the units with your eyes as you go along. And if they're all the same, meters, 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 seconds, seconds, we're good. But if you see, kilometers and meters, or if you see seconds and minutes or seconds and hours, we are going to have to do some conversions. So I said to you, Jada, I always go back and I look at the question looking for numbers and eventually also physics words. You don't know any of the physics words yet, but we'll get to there. First number I see is the 18. What are the units next to that 18? Meters per second, not miles. We're a proud Canadian. Meters per second. That's a speed. Except, okay, Jada, what do they want my answer to be in for part A? I think my easiest approach is going to be leave this as hours and convert this to kilometers per hour. And the reason I think I'm going to do that, we wrote down a shortcut on our formula sheet. It was something to do with a 3.6. Can't remember what, but we'll get that. So I'm going to write down V equals 18 meters per second and put an equal sign right next to it. How do I convert that to kilometers per hour, Jada? Is it times by 3.6 or divide? So on your sheet, you wrote it on the bottom. You don't need to memorize it. This is my way of saying, everybody look and make sure you know where you wrote this on your formula sheet yesterday. You did. So going from meters per second to kilometers per hour, is it times by 3.6 or divide? Times by 3.6? Is that right? So 18 times 3.6 is what? And you're all typing on your calculator, aren't you? I told you, I'll call you on it. Yeah. 64.8. Okay, and I'm not going to round that off. If there was a whole bunch of decimals, I might round it off, but whenever possible, I'll try and use the whole value. 64.8, and that's now kilometers per hour. Okay, let's keep reading. Jada, what's that 2.5? What are the units next to that 2.5? So it's got to be a time, right? Okay. This will work just fine, I think. It wants me to find distance. I'm going to say, okay, I'm going to use my distance equation, D equals VT. Normally, I don't put the units in my work, but I'm going to this time, Jada, just so you can see how this all fits together. The speed is 64.8 kilometers per hour, and the time is 2.5 hours. Jada, can you see the hours cancel, and can you see the only units left behind are what? kilometers. That dimensional analysis shtick I showed you at last unit, that also works if you're paying attention. You can tell if you set the question up right, because you will end up with the correct units. I don't always use that trick because I get good enough that I know I'm right, so I'm going to be lazy. Is that a hand up?
Yeah.
Yeah.
Also convert the hours into seconds.
You could, and then you could, so the other option, you're right, I could have converted this into seconds. That would have given me B first. That would have given me the answer in meters, and then I could go to kilometers. And either of those, I'd give you full credit. What do you get? 64.8 times 2.5. Probably 180 something, 160 something, sorry. Point what? Even? 162 even? And Jada, what are the units for that? Yes, we know that because we deliberately constructed it that way. To do B, I could do Mika's method. I could convert this to seconds, use this, and this would give me an answer in seconds doing exactly the same thing. I think it's going to be quicker, though, to convert 162 kilometers to meters. And I'm naturally lazy, so I'll do the quicker method. For part B, I would write down what they gave me, 162 kilometers. I want kilometers to cancel. Kilo is 10 to the what? It might be worth, and this is totally up to you, but I know over the years I've memorized if I want to go from kilometers to meters, it's just times by 1,000, and I can do that in my head. If I want to go from meters to kilometers, it's divide by 1,000. And the reason I've memorized that, I got a driver's license, and it shows up on roads. They sometimes give you distances in meters, especially when on-ramps and off-ramps are nearby. I thought about writing this in scientific notation, 1.62 times 10 to the 5th, and I thought it's about the same amount of writing no matter what, so I left it like that. It's up to you. Totally fine. So one of the things you want to look for when you're doing the homework is, are the units good? If the units don't all match, you'll have to convert something. Sometimes a speed, sometimes a time. And you'll either convert everything to kilometers and hours if the question wants an answer in kilometers or hours, or you'll convert everything to meters and seconds if the question wants an answer in meters and or seconds. Have a little thought puzzle here. It says this: an object can have a positive distance while having a displacement equaling 0. True or false? You're going to find in physics, I'll be giving you a lot of thought puzzles, probably about 300 or 400 before the year is over. In fact, when we get to forces, every time you walk into the room, there will be a little thought puzzle for you to ponder. And the way we're going to do it, we're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Duke will make fun of me if I don't vote. And Mr. Duke will make fun of you if you don't vote. The one rule in my class is you have to at least make a hypothesis, make a guess. Okay? So here is our first thought puzzle. It says this: an object can have a positive distance while having a displacement equaling 0. And you're going to vote either true or false. So we're going to start out. Here we go. Who says true, Mr. Dewick? The answer is true. Okay, hold them up. Counting 1, 2, 3. Is that a hand? 1, 2, keep it up. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Who says false? 1, 2, 3, 4, 5. 5. It's always so. Then what I always say is, convince me. So you have an option. You can either attack someone else's answer as, I know they must be wrong, or you can defend your own answer as, this is why I know I'm right. So those of you that voted true, those of you that voted false, convince me. Convince me. Mika, which one are you defending? True? He's absolutely right, but that's way too much writing. But you're totally right. I'm going to go to an even simpler example. 2 steps forward, comma, can you fill in the rest of it? 2 steps. Hello? Yeah. That'll get, what would the distance here be? 4. What would the displacement be? 0. In fact, if we were really lazy, we could have said 1 step forward, 1 step back. So, true. We gave an example where that could happen. And yes, also throwing a ball straight up into the air and having it come back to where it started from, totally good. Just too much writing, but yes, I would have given you full credit if I'd asked a thought puzzle like that on the test. In Physics 12, I will ask thought puzzles on tests, but we build up to it in Physics 12, where you'll start to be asked to prove or convince me more and more. Physics 11, we'll just do these orally in class all the time. Ooh, example 11. True or false? An object can have a positive distance while having a negative displacement. An object can have a positive distance while having a negative displacement. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Positive distance while having a negative displacement. Okay, time to make your call. Who says true? Okay, now I'm watching. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. False. I think everyone voted true, so convince me. Cool. He is absolutely right. You could take 2 steps forward and 3 steps backward, or if you're lazy like me, you could take 1 step backward and accomplish the same goal, because you would have a negative displacement, -1, and still a positive distance, 1. But yes, I would totally give you credit for yours as well. But I'm naturally lazy. I'll type less if I can. Okay, smarty peoples. Example 12. An object can have 0 distance while having a positive displacement. Ooh. 0 distance while having a positive displacement. All right, now is the time for you to vote. Again, how high you hold your hand up is how sure you are of the answer. So who says, yeah, Mr. Dewick, I think that's true. We can have a positive, 0 distance and have a positive displacement. I got 1. Anybody want to join our lone survivor there? Is that it? No, Eric, that you're just pointing the pen at your, okay. Be careful, because if you adjust like hair number 93, I might think you're voting, right? Okay, we got 1. Who says false? I think, what do we have in this class? 18, so 17 humans. Convince me. Convince me. Yeah, Jonah, I saw you start to raise your hand like you had a thought. I saw you look around like, I have a thought, but nobody else is. You have a thought. Go for it. Convince me.
If you don't move at all, you can't displace.
Okay. For 0 distance, how many steps am I allowed to take as a number exactly? Be honest. You know this. 0. So if I'm not allowed to take a, remember, displacement was your change in position. If I can't take a step, can I possibly change my position? No. So I think, sorry, Cole, but I respect you going out on a limb. By the way, the thought puzzles get tougher and tougher, and so there will be some where if you think, I'm going to pick the one that everyone thinks is wrong, you might be right, because it's a really, really tricky one. So, you know, hold your ground, my friend. Hold your ground. Carry on. D equals 0 means no steps, comma. So no delta position. What's delta an abbreviation for? If you can write the word change in if you want to, but hopefully I've told you that I do tend to abbreviate. We're going to use that. Those of you that are planning on going to university, by the way, you will find when you get to post-secondary, there is a shorthand that all students have just kind of evolved over the years. For example, I remember that's the word with, that's the word which, that's therefore. That's because. There was a shorthand that you just kind of pick up. You'll see people next to you using all sorts of weird symbols, and you'll just figure it out because nobody can write as fast as the profs talk. Next page. One of my favorite comics is Foxtrot. This is a Foxtrot comic. The author, Bill Ammond, actually has his physics degree, and he'll sneak some good physics in quite often. He was doodling a lot when he was in university. His friends said, you know, these are kind of funny. You should try publishing these. So he writes about a family. And in the family, the youngest boy, Jason, is the nerd. You might not be surprised to hear that I really empathize with Jason, the nerd. So here is Jason, the youngest boy, the nerd, playing football with his older brother, Peter. Jason is the quarterback. He says this, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and hit you with the ball. Peter thinks for a while. Won't I be right back where I started? Jason says, I can't throw very far. So my first question, what distance will Peter run in order to complete this play? Well, I guess it's just going to be every number that I see in the bubbles. So I see a 40 and a 20 and a 25 and a 30 and another 30 and a 10 and a 15 and a 20 and a 50. What do you get? I can do this in my head. It's going to be 40 plus 20. It's going to be 60. It's going to be 85. It's going to be 115. It's going to be 145. It's going to be 155. It's going to be 170. It's going to be 190. It's going to... Double check me. You get 240? Eric's going to type on his calculator before I call him out. Oh, I just did. Sorry. Is it 240? Yep. So... And I guess the units here would be yards because it's American football. If Peter ends up back where he starts from, what's his displacement as a number exactly? I'm not going to do it today, but I have on the linear system, we're often getting to this in September, at the end of September, when it's still nice out. I have taken the kids out to the football field, and Claudie, we have run this play, and you do end up back where you started from. The physics is good. I've checked it. I had to. Okay? So what we're going to be using in the homework and in the activity that we're just about to start is the idea that D equals VT. This also means that V equals D over T. And it means that T equals D over V. You can write those down if you want to. By the end of next week, I won't let you write them down. I'll make you derive them in your brain because that's a better way to do it. Can you see how I got this second equation? How would I get the V by itself? What's the T doing to the V? So, Zana, how would I move the T over? Divide. So you can see that's hidden in there. Oh, and how did I get the T by itself? Well, what's the V doing to the T? Well, so what did I do? So if I give you this, you can get those, okay? I had already assigned, you could try 1, 2, 3, 4, 5. You can also handle now number 6. You can handle number 7. What's yucky about number 8? Okay, now, and it wants an answer in meters. I think what I would do is I would convert this to meters per second, something to do with a 3.6, and I would convert the 3.2 minutes to seconds. If you have meters per second and seconds, you will get an answer in meters. I would probably do it that way. Number 9 is fair game. Number 10 is fair game, and I did attach the answers so you can check your answers as we go. So that brings us to the end of the lesson. And now we're going to move on to a little activity. You'll have the rest of class to work on the activity and work on the lesson, but let me hit pause.